When Mount Pinatubo erupted in the Philippines June 15, 1991, an estimated 20 million tons of sulfur dioxide and ash particles blasted more than 12 miles high in the atmosphere. The eruption caused widespread destructions and loss of human life. Gases and solid injected in the stratosphere circled the globe for 3 weeks. Volcanic eruptions at this magnitude can affect the global climate, reducing the amount of solar radiation reaching the Earth's surface, lowering temperatures in the troposphere, and change atmospheric circulation patterns. The extent to which they occur is ongoing debate. Large-scale volcanic activity may last only a few days, but the massive outpouring of gas and ash can influence climate patterns for years. Sulfuric gases convert to sulfate aerosols. Submicron droplets contains about 75% sulfuric acid. Following eruptions, these aerosol particles can linger as long as 3 to 4 years in the stratosphere. Major eruptions alter the Earth's radiative balance because volcanic aerosols absorb terrestrial radiation and scatter a significant amount of the incoming solar radiation, one effect known as radiative forcing that can last from 2 or 3 years following a volcanic eruptions. So, volcanic eruptions cause short-term climate change and contribute to natural climate variability, say Georgy Strenchikov, a research professor of the Department of Environmental Science at Rutgers University. Exploring effects of volcanic eruptions allow us to better understand the important physical mechanisms in the climate system that are initiated by volcanic forcing. Nowadays, most of what Earth stays on Earth. Very little material is added by meteorites and cosmic dust. The only material lost to space is in the space hardware. However, meteorite impacts have contributed to climate change in geological past. A good example is the Chicxulub crater, Yucatan Peninsula in Mexico. Large impacts such as this one can cause a range of effects that include dust and aerosols being ejected high in the atmosphere that prevents sunlight from getting through. These materials insulate the Earth from solar radiation and cause global temperatures to fall. The effects can last for a few years. After the dust and aerosols fall back to the Earth, the greenhouse gases, remember carbon dioxide, water, and methane, caused by the interaction of the impactor and its target's rock, remain in the atmosphere and can cause global temperatures to increase. The effects again can last decades. Human activities contribute to climate change by causing changes in Earth's atmosphere in the amounts of greenhouse gases, aerosols, that's small particles, and cloudiness. The largest known contribution comes from the burning of fossil fuels, which release carbon dioxide gas to the atmosphere. Greenhouse gases and aerosols affect climate by altering incoming solar radiation and outgoing infrared, thermal, radiation that are part of the Earth's energy balance. Changing the atmospheric abundance or properties of these gases and particles can lead to a warming or a cooling in the climate system. Since the start of the industrial era, about 1750, the overall effect of the human activities on climate has been a warming influence. The human impact on climate during the era greatly exceeds the due to known changes in natural processes, such as solar changes and volcanic eruptions. As the concentration of carbon dioxide in our atmosphere has increased since that time, so everything has temperature also has been steadily increased. In other words, there is a strong correlation between more carbon dioxide and higher temperatures. And while the amount of carbon dioxide in our atmosphere has gone up and down over time, all the coal, oil, and gas we have burned over 2+ centuries mean it hasn't been this height for hundreds of thousands of years. We are simply adding more carbon dioxide in our world that it can be absorbed. Warm temperatures aren't the only fingerprint humans have left on our changing planet. Our oceans have become more acidic. We are seeing more extreme weather events, maybe like hurricanes and wildfires, and the world's glaciers and sea ice are melting, and that is just the tip of the iceberg. It's clear that we need to make the switch to clean, reliable sources of renewable energy like solar, wind. Unlike fossil fuels, renewables don't add greenhouse gas to the atmosphere. What they do is they are better for our planet and for our health. Impacts from climate changes are happening now. These impacts extend well beyond an increase in temperature affecting ecosystems and communities in the United States and around the world. Things that we depend upon and value, water, energy, transportation, wildlife, agriculture, ecosystems, and human health, are experiencing the effects of a changing climate. Changed water resource can have a big impact on people's lives. In some regions, particularly in the western United States, drought is an important factor affecting communities. Less snow accumulation in the mountains is important in the West and Alaska, where the snowpack stores waters for later use. In the Midwest and northeastern states, the frequency of heavy downpours has increased. In many regions, floods and water quality problems are likely to be worse because of climate change. Our food supply depends on climate and weather conditions. Although agricultural practice may be adaptable, changes like increased temperatures, water stress, disease, and weather extremes create challenges for the farmers and ranchers who put food on our table. The human health is vulnerable to climate change. The changed environment is expected to cause more heat stress, an increase in weather-borne disease, poor air quality, and disease transmitted by insects and rodents. Extreme weather events can compound many of these health threats. Ecosystems are also affected by climate change. Habitats are being modified. The time of the events such as flowering and egg laying are shifting, and species are altering their home ranges. Changes are also occurring in the ocean. The ocean absorbs about 30% of the carbon dioxide that is released in the atmosphere from the burning of fossil fuels. As a result, the ocean is becoming more acidic, affecting marine life. Rising sea levels due to thermal expansions can melt land, ice sheets, and glaciers, put coastal areas at great risk of erosion and storm surges. Sea ice extent is a measurement of the area of the ocean where there is at least some sea ice. Usually, scientists define a threshold of minimum concentration to mark the ice edge. The most common cutoff is at 15%. Scientists use the 15% cutoff because it provides the most consistent agreement between satellite and ground observation. Scientists tend to focus on Arctic sea ice extent more closely than other aspects of the sea ice because the satellites measure extend more accurately than the other measurements, such as a thickness.
Without substantial change getting the greenhouse gas emissions down, we are on a path to large increases in the planet's temperature. You hear a lot about the progress in reducing the cost of renewable energy to make electricity. But generating electricity isn't the only contributor to climate change. It accounts for only about 25% of all greenhouse gas emissions. With greenhouse gases, you have the electricity sector, but you also have manufacturing, transportation, agriculture, buildings, as well as about 10% from other sources. We need innovation, going out there and finding inventors across all these different areas and understanding their energy R&D activities to make sure that they have a path from their laboratory to scaling up into very large numbers. For electricity, wind energy and solar energy, prices are coming down. So the electricity sector has to either be able to store that energy or have other zero-emission sources to maintain the reliability that we all depend on. Manufacturing. Here we're talking about all the stuff we buy. Furniture, beds, the cars themselves, all of those things. Just the very process of making cement is CO2 emitting. There's a lot of embedded energy. We'll have to change the way that we do that manufacturing. Transportation, immediately people think about passenger cars, and they are a big part of that. But transportation is quite broad. We've got railroads, we've got ships, we've got planes, and so every one of those has to get to zero emission. Agriculture. This is a category that often people forget about. Cows actually emit quite a bit of methane, which is one of the more powerful greenhouse gases. And so inventions like artificial meat may have to play a role here. Buildings. We need to invent different processes in order to get the energy used in running all these buildings down, way down to zero. The path to success is going to require innovation across every one of these sectors. So it is quite daunting. During this century, we not only need to invent all of these things, we actually need to deploy them at massive scale. But in my experience, innovation can do magical things.